We're now going to begin discussing the idea of solving a triangle using the law of sines. When we solve a triangle, we are being asked to find the measurement of all three sides and the measurement of all three angles. The law of sines is one way for us to do that. When we look at a triangle, we need to first realize that as we label that triangle, we're going to use capital A, capital B, and capital C to represent the sides of that triangle. So I'm going to draw a triangle here and just show you how a triangle is going to be labeled in order to work for law of sines. Now for law of sines, we're specifically looking at a triangle that is not necessarily a right triangle. So we're going to have angle A, another angle which we'll call B, and another angle which we'll call C. Now, the lowercase letters A, B, and C represent the side lengths of the triangle. And the one thing that we have to be careful about is that the angle and the side have to have an opposite relationship. So if, for example, this is angle A here in the bottom left of the triangle, then opposite that angle, we're going to have side A. And if we have angle C in the bottom right of the triangle, then opposite that, we're going to have side C. And if angle B is at the top, then opposite that, we'll have side B. And so you want to be sure as you label your triangle with your letters that you are holding that opposite relationship in place between the angle and the side. Now, once we have that, let's look at our law of sines. It says, given a triangle with sides and angles labeled according to the convention on the previous page, which is what we're talking about right here, then we have this set of ratios. Sine of angle A divided by A is equal to sine of angle B divided by B is equal to sine of angle C divided by C. So we're going to look at a few examples to see how we work problems using this law of sines. So let's begin with this example. It says Sarah is piloting a hot air balloon and finds herself directly above a long straight road. She notices mile markers on the road and finds the angle of depression to the two markers as shown below. Okay, so we want to be sure, first of all, that we understand what is being discussed when they discuss an angle of depression. So an angle of depression is the difference between looking straight ahead at something and looking down at something. Okay, so for example, if she is sitting in the basket of the hot air balloon and she looks straight out, then her line of sight goes this way. And if she looks down at the mile marker, her line of sight goes this way. And so the difference between those two is an angle of depression. And so they're telling us that one of those angles of depression is 50.19 degrees. Okay, and then we have the same sort of thing on the other side. If she looks straight out, this is her line of sight. If she looks down at the mile marker, this is her line of sight. So the angle of depression lies in between, and they tell us that that one is 15.66. And so the question that we're being asked, first of all, is how far is she from marker A, all right, which would basically be finding this side of the triangle. And then what is her altitude? What is her height, which would be finding H in the picture. Okay, so we're going to begin by taking this picture and doing a little bit of work with it. Okay, so I'm going to erase my scratch work there, and let's talk about what we know. So, first of all, I want us to look at these angles that take us from one side to the other. All right, so we know that an angle that goes straight across is 180 degrees, correct? All right, so if we just go straight across on that top dotted line, we know that it's 180 degrees. So what should be true is that if we take these three angles, the 15.66, the angle from here to here, and also the 50.19, that those three angles should add up to 180. So the first thing I want to do is I want to find that missing angle in the middle. And so I'm going to take the 180, which again is the total from one side to the other. I'm going to take off the 15.66. I'm going to take off the 50.19. And when I subtract those two angles, I'm going to be left with 114.15 degrees. And so that's going to be the angle in the middle or at the top of our triangle. Okay, so that's one thing that's going to be helpful to us as we start working this problem, is to know this angle measurement at the top. Okay, the other thing that's going to be helpful is to know at least one of these angle measurements at the bottom. So I'm going to work at figuring out what this one is, what angle B is for this triangle. Now, in order to do that, I'm going to need to look at my smaller right triangle, the one that's sitting on the right-hand side. So I'm going to come off to the side somewhere and just kind of sketch that right triangle. All right, so we're trying to find this angle, which is angle B. And we know that this side is H, and it appears at the beginning that that's at least all we know. But we actually know a little bit more, because we know that we have a right angle here. Okay, and we also know that if I extend this dotted line out across the top, okay, right here, we also know that this is going to form another right angle. And furthermore, we know that this part is 50.19. So I'm going to argue here that I could find this angle at the top of my triangle using those two facts, using the fact that we have a right angle, which goes from here up, and we already know that part of that angle is 50.19. So I'm going to take 90 degrees, which is my right angle. I'm going to subtract off 50.19. And that is going to give me the angle at the top. So that angle is going to be 39.81. Okay, so let's clean that up just a little bit and put that in there. All right, so we know that this angle is 39.81 degrees. We know we have a 90-degree angle here at the bottom, which now we have two of the three angles in the triangle. So now we have two of the three angles in the triangle, and we can go in and find the third one. Remember that your angles in a triangle add up to be 180. So if we take our 180, which is the total, we take off the 39.81, which is the angle at the top. We take off the 90 degrees, which is the angle at the bottom left. Then we should be left with that angle at the bottom right. And so that angle would be 50.19. And if you remember from geometry, that's not necessarily surprising, because we know that when we have two parallel lines that are cut, we have opposite angles being equivalent. And so we shouldn't be surprised that we get 50.19 down here and we have 50.19 at the top. Okay, so I think at this point we have enough information to actually go in and try to find what we're looking for. Okay, so I'm going to take my triangle here, and I'm just going to pull it to a new slide, and let's look at what we've got, and let's look at trying to find the answers to the questions that were asked. All right, so here's our triangle. Everything is marked and labeled. The only thing additionally on this triangle that wasn't on the other is this measurement at the bottom. And so you might be saying, okay, where did we get the 5280? Remember that we're talking about the difference between 2 mile markers. So we know that the difference between A and B is 1 mile. And remember that 1 mile is 5,280 feet. So we do know this distance at the bottom of the triangle. Okay, so what I'm going to do first, the first question asked me to determine how far she was from marker A. So remember that that is finding this side B. And so we want to work on that first. All right, we're going to use our law of sines, and we're going to set this up, definitely using the ratio that has the B's in it. So I'm going to go ahead and just kind of jot this down, sine angle B over B. And then we also want to use the ratio that has the C's in it, because we have angle C and we also have side C. Remember that the angle and the side opposite it match up in terms of the letters. So I'm also going to go with sine C over C. Now note that even though law of sines has 3 fractions, we tend to only use 2 at a time. Okay, so let's plug in what we know. So I know that angle B is 50.19 degrees. And I know that side B is what I'm looking for, so I'm going to leave that in there. Angle C is 114.15 degrees. And side C, the side opposite that, is 5,280. Now we're solving for B. The easiest way to solve this thing is to cross multiply. So we're going to multiply the sine 50.19 times the 5280. So I'm going to have 5,280, and we're going to put this in our calculator in just a minute. And then the sine of 50.19 degrees. And then we're going to multiply across the other direction. So that'll give me B times sine 114.15 degrees. Now again, remember that you're solving for B, so you need to get B by itself, and so we are now going to divide both sides by this sine 114.15. All right, which will cause it to cancel over here, leaving me just B. And what I have on the left-hand side, I can go ahead and type it in my calculator. So you want to be sure that your calculator is set in the degree mode, and then you're going to enter that in. And so when you do that, you're going to come up with 4,444.98 feet. And it looks like our book is asking us to round this to a whole number. So I'm just going to go ahead and say 4,445 feet for our answer. All right, and so that will be side B. And that will be how far she is from mile marker A. Okay, we're also asked to find her altitude. And so that is going to be the height, remember, from the balloon, which is up at C, straight down. And so they called this H in the previous picture. And so our job now is to find the H value. All right, so let's think about how we can do that. Now, we're going to use this angle over here, which we don't have labeled, but we certainly can label it. All right, so we know that the angles add up to 180 in the triangle. So we have 114.15, we have 50.19, so we can find that missing angle. All right, so let's go ahead and do that real quick. So I would take 180, I would subtract off 114.15, I would subtract off 50.19. Okay, that should leave me with that one missing angle that I don't know. All right, so that leaves me 15.66 degrees. Okay, so how would we do this? Well, to do this, we're really going to look at this as being a right triangle problem. So I'm really specifically going to look at this triangle right here, which is a right triangle. And remember that if we're dealing with a right triangle, then we can pull in one of our trig functions and our SOHCAHTOA definitions. So look at what we've got. We're going to use this 15.66 degree angle, and we're looking for the opposite side. And we have the hypotenuse of that triangle. So if we have the opposite and the hypotenuse involved, then it should be a sine problem. So I'm going to set up a ratio that looks like this. I'm going to say sine of my angle 15.66 degrees is equal to the opposite, which is the h that we're looking for, over the hypotenuse, which is the 4445. Now, if you want to be exact, you would want to use this value 4445 with some of the decimal values, which may give you a little bit more precise answer. All right, but for our purposes right now, we're just going to go ahead and calculate with the 4,445. Now, we want to solve for h, which means the first thing I want to do is I want to get rid of that fraction. And I'm going to get rid of the fraction by multiplying both sides by the denominator, causing it to cancel over here and giving me 4445 times sine of 15.66 degrees. And again, this is something that I can put in my calculator. So I'm going to type in 4445 times sine of 15.66, and I come up with 1199.83 feet for my height, which again, the book is asking us to round these things to whole numbers. So that's going to be approximately 1,200 feet for her altitude. Okay, so that's one example of how we use the law of sines. We're going to stop here for this presentation, and then we're going to look at several more examples in the next presentation.